All right, we're into post 4 now on Order Entry User Interface series. We've already looked at some general order entry requirements, examples of existing order entry systems, and the difference between order entry and order customization. This post wants to take a step back and think from first principles about why do orders even exist. We'll then look at some different types of tools which can achieve this first principle understanding, and then look at the gap between how you would think about order entry from first principles versus how these actual tools function today. Again, like the previous post, there aren't any visualizations or images you need to look at, so you can listen to just the audio on this one. All right, so first, part 1, why do orders even exist? And the key thing here is that in healthcare, an order makes something happen. So if you want a simple takeaway, an order turns knowledge into action. And patients will come to see a physician to consult their expertise. The physician will assess the problem and then order the next step, which might be a test, a medication, or a referral. And so what's happening here is the physician has knowledge. They use the order to take that knowledge and turn it into an action. And one of the key concepts, though, that I want to underline is that the order is something that overlaps the concept of knowledge and the concept of action. And this is very different than, I think, the way that most people view an order. Most people view, I think, an order as a dumb messenger service and something that links knowledge to action, but that doesn't overlap into knowledge and doesn't overlap into action. And so in this post, we're going to explicitly highlight the importance of why the order overlaps into knowledge, and then in a subsequent post, we'll look at why the order needs to overlap into action. Just one aside, I'll use today the term physician as the person who's ordering stuff. And I'd prefer to use the term clinician because I think a lot more health professionals should be ordering things. But that idea kind of begins to freak people out, and there's already enough heresy in this post. If you're particularly interested, there's a link I gave to a talk at Stanford Medicine X called Breaking the Medical Cartel in the blog post, and you can see that for further information. All right, so let's go into this knowledge and orders part in a little bit more detail. In order to place an order, 2 types of knowledge are required. First, knowledge of what is wrong, and second, knowledge of the next step. So the knowledge of what is wrong, in theory, if we had this benevolent artificial intelligence system, the computer would just know the problem the patient has and the solution. It would know the whole process. And this would be very helpful because the system could alert the clinician to lab findings that the clinician may have missed and results that the clinician may have not even seen. But for simplicity in today's arguments, let's assume that the knowledge of what is wrong, the knowledge of the problem the patient has, is still in the domain of the human or of the physician. Then we look at the second part of knowledge you need to place an order, which is knowledge of what the next step is. And I think it's important to realize that there is a very wide spectrum between the knowledge the physician has about the next step and the final order. Let's go through a few examples, 7 of them. The first is a physician may understand exactly what needs to be ordered, and they therefore need a tool that allows them to enter that order as quickly as possible. In this case, the physician has perfect knowledge and perfect accuracy. Now, unfortunately, I would say that because we're human, this is the exception and not the norm in the placing of most orders. The second example is a physician who thinks that they know exactly what antibiotic should be ordered, and they go to use the tool as the physician in the example above, but in fact, the medication they've selected contradicts the patient's allergy history. The dose they were going to prescribe does not fit with the patient's renal function. The medication itself is ineffective because the patient is known to be resistant to the drug. And so, in this case, the physician had alleged complete knowledge, but they were unknowingly completely incorrect. Another example here of how knowledge leads to order. We have a physician that knows they need an antibiotic, but they may not know which drug, its dose, or the dosing interval. So here's an example of partial knowledge of the next step. A second example of partial knowledge of the next step is a physician that knows that blood pressure pills should be added, but they don't know exactly which one is the best next pill to add based on national guidelines. In the fifth example, we have a physician who's a physician in training and they know the potassium is too high, and perhaps the only reason they know that is because the nurse told them, but they have no idea how to bring it down. And so we have, in this case, very partial knowledge of the next step. In example 6, there's actually two examples combined, and these are on the theme of a physician may outsource the specific details of the next step. For instance, the physician may have the patient on a blood thinner, warfarin, and this gets titrated related to their blood coagulation, their INR. But they may outsource the actual orders to another clinician, such as a nurse. And so in this case, the physician might set what the parameters and the range for the order is. They have the knowledge of the parameters, but the details are outsourced. A second example, a physician may outsource the titration of a patient's insulin dosing, but instead of outsourcing it to a nurse to manage, they might outsource it to a computer algorithm. So again, there's knowledge of the parameters and desired outcome, but the specific details are outsourced. And in our last example, we have a physician that doesn't even realize the patient's antibiotics should have been stopped or that the diuretics should have been held, and the system alerts the clinician to this. And this actually probably falls more into that first category, which we aren't focusing on, where there's a lack of knowledge of what is wrong. What I want you to take away from these examples is that in each case, there's a gap between the physician's knowledge and the ability to write a detailed, complete order. And this gap may be from either a lack of knowledge, it might be from mistaken knowledge, or it might be from outsourced knowledge. And each of these is normal and just part of day-to-day healthcare. Now, traditionally, in order to close this gap, physicians may look up the correct answer in a book or on a website or use an app, or they may read the guidelines. But the important thing to realize is that none of those types of ways to close the knowledge will catch the cases where the physician thinks that they know what the next step is, but are in fact entirely wrong. And so this highlights the need for the order entry process to, in real time, double-check the order. And just to highlight one of the other concerns with the ways that physicians may try to close this gap is that because there are order sentences in medical record systems, meaning that when you type in a drug, it shows potential dosing options, I've heard on multiple times people tell me that they don't know which drug to select or what dose to select, so they just pick one. And they, quote, know that the pharmacy will call them back and correct it, end quote. I've heard this multiple occasions. Different people have talked about this problem before. And as you can imagine, it's highly risky and a highly dangerous practice. And so this is an example where there's no knowledge of the next step, but the person orders something anyway. All right, let's think about what big conclusion we can take away from this understanding about knowledge and orders. As you can see, the actual order itself must be understood in its relationship to the knowledge required if it's correct. And so this applies to both helping the guide the orderer to what the correct order is, such as when they don't know the right drug or the right dose. And it also involves continuously checking the order in real time to ensure that the clinician's request is reasonable. Unfortunately, most medical record systems today, the tool functions more as a dumb messaging service. It doesn't assist the clinician in what they should order, and it does not validate in real time the appropriateness of that order. Now, of course, yes, there are drug interaction flags, but those are actually more alert fatigue than useful information. Given the tight connection between knowledge and the ordering selection process, you can think of many different types of tools to help with ordering that could be invented to help with this process. So let's move into part 2, looking at some types of order selection tools. We'll just look at 3 examples. The first is a rational antibiotic selection tool. So as discussed, the tool would help the clinician through the process of selecting the right antibiotic. The tool could take into consideration the patient's source of infection, past allergies, the patient's past microbiologic resistance pattern, the hospital and region's antibiotic resistant patterns, the patient's preferences for dosing intervals, recent and concurrent medications, the patient's level of sickness, the availability of stock in the hospital, the cost of drugs. Many factors go into such a decision. And potentially a tool like this could help aid in the selection of the right antibiotic and the right dosing. And so this is a tool which helps with selection as well as verification of what was entered. In a similar way, even if the physician may not need the use of such a tool because they know exactly what drug to enter, this tool could function in the background and verify that what was entered, in fact, does fit with the appropriate above parameters. The second example of an order selection tool would be one that may do automated warfarin dosing or automated insulin dosing. As discussed in the earlier examples, a clinician may outsource future orders for a specific issue to another person or to another tool. And so it's easy to imagine a physician entering parameters for what the patient's blood thinner should be or what their target insulin dose should be, and then the computer takes care of the rest. The algorithm takes into consideration the patient's previous values, medication compliance, diet, etc. There's actually been several papers showing the ability of computers to exceed clinicians in being able to anticipate the appropriate dosing for a patient's in-hospital insulin dose. And you could imagine that such a tool may initially ask a clinician to sign off and to confirm each order, and then in the future only perhaps confirm those requests which are at the edge of an algorithm's confidence. And so ultimately, such a tool over time would leave the confines of an electronic health record for physicians and migrate itself to being able to be used directly by patients. And so this is an example of a tool for outsourcing orders, automating orders, and providing order suggestions. The third here is an example of a diuresis dosing tool. Patients may be in the hospital requiring to be on diuretics, which might, for instance, be helping get rid of increased water in their system from heart failure. And this may be a decision that takes into consideration multiple measurements, such as the patient's physical exam, their lab work, their comorbidities. And these metrics help assess if the diuretics should be increased, decreased, or remain the same. You can imagine a diuretic dosing tool which could be activated for a patient and then propose on a daily basis the next steps. And ideally, the clinician would want to not just see the output from such a tool, such as increased furosemide to 80 milligrams POBID, but they probably want to see all the information that this tool is using in its decision and see the trend lines, see the patient's weight, see their inputs, their outputs, their creatinine, different physical parameters, their symptoms, and see all of this in a nice integrated graphic and visualization. And so perhaps this is a type of ordering tool which actually would be embedded directly into the clinical note so that these trends would be documented as part of the daily documentation. And so this is an example of a tool, again, showing automated order suggestions, visualization summaries, and automated documentation. Overall, what you're getting is an idea that the order process needs to be context aware, that it needs to understand who the patient is, if it's a child, an adult, or a pregnant lady, because this will all permit different types of dosaging and drug formulations. The system needs to know who is placing the order. For instance, if the physician is a cardiologist looking at beta blockers, they're going to be probably wanting drugs for heart rate control, whereas if the physician is an ophthalmologist looking at beta blockers, they're going to be wanting drugs for the patient's eyes. Similarly, depending on the role of the clinician, the system might limit the types of medications or the drug thresholds that can be ordered by different types of clinicians, such as a clinical officer versus a nurse practitioner versus a physician. There's also needs to be context aware around the routes that are available. Can this drug only be taken intravenous or oral? And similarly, there needs to be awareness in the system as far as the routes that the patient has available to consume medications. If the patient is NPO or not able to take anything by mouth, what is the preferred drug route? Does the patient have a nasogastric tube or a PEG tube or an IV? Ideally, the drug orders should automatically default when someone begins to place an order to the permissive routes that the patient has to take in the orders. There needs to be consideration automatically in this context-aware system of what doses are permitted. Is the drug being ordered new and therefore needs to be started at starting doses? What are the appropriate dose increments for such a patient? What are the dose increments for a geriatric patient versus a young patient? And then there's also needs to be context aware about the patient's physiology. For instance, do they have renal impairment, liver impairment? Again, all this affects dosing suggestions. And so this is why the placing of an actual order is more than just the use of a dumb piping system or a dumb messenger system to move from the, quote, knowledge to the action. The actual placing of the order needs to involve a considerable amount of knowledge, helping the physician close the knowledge gap, and verification of the knowledge that the physician applied is appropriate to the situation. I did mention in the previous post discussing the difference between order selection and order customization that these tools for ordering will need to be placed in many different types of locations in the electronic health record. And so let's just look at a few of these to understand, again, the incredible variety which one finds himself when thinking about ways to do order selection. For instance, one option would be a clinician might be filling out a hypertension assessment form, and at the end of the form, they realize that the patient has new mild hypertension, and there's, in this case, let's say 3 medications that they can start at their local dispensary. And so the order selection tool might just be a single button for one button for each of these 3 pill options within this form. In a separate case, you might have the patient come back to the same clinic, and in this case being seen in the follow-up form for their hypertension. And so at the end of the form, there might be, again, perhaps 2 buttons, which are 2 different options to increase the dose that they're already on. You might have another example where a physician is reviewing their to-do list, and if a medication should be stopped, the system will automatically insert the order to stop the medication into the physician's to-do list. Another example is that a clinician might be looking at a patient's blood work and notice that some blood work should be repeated. And perhaps the order placement to repeat the blood work is right within that blood work review panel. You might have another example where you have an inpatient and a physician just wants to open the electronic record as quick as possible and enter something immediately. And perhaps in this case, they launch a generic order entry tool. You might have another example where the clinician is messaging another clinician for advice, and then within that chat window, they want to convert the message to a formal referral. And so as you can imagine, what we've been discussing is there's an incredible amount of new possibilities on how ordering can take place within healthcare. Ultimately, ordering needs to assist in the knowledge component, and the ordering needs to integrate very deeply into the workflow component. Ordering shouldn't be a separate thing that people pull themselves out of their workflow to do, and it shouldn't be something which is disconnected from their actual linkage of knowledge to action. And so, although a lot of what I've been discussing sounds far too futuristic, you can imagine a lot of very simple tools. For instance, if you're writing a note about blood pressure, when you open the order tool, that it would rank blood pressure pills at the top of the order entry search box. But again, you could imagine a lot of very sophisticated ordering tools using much more complicated algorithms, taking into consideration patients' comorbidities and provide a lot more clinical assistance to the person ordering the drugs. And this is super important because the long-term goal ultimately in healthcare is to be able to scale healthcare, and the only way to do this is without physicians. And so if we can have tools embedded into electronic health records, which can allow a nurse or a community health worker working in a rural developing nation to be able to function at a much higher level than their clinical training suggests, it really provides a lot of the answers as far as being able to provide healthcare at scale. But now let's get back to reality in part 3 and discuss the gap between these first order principles as far as how ordering should be done versus how actually ordering is done today. And as I mentioned, the two big problems are that ordering today doesn't provide sufficient advice in helping close the knowledge gap between what the next step is and the order, and ordering systems today don't allow a sufficient verification in real time if the order makes sense. And therefore, what we need to do is not think of order entry as a single tool that you open up separate from your existing workflows, and that provides just a generic list of orders. But we need to think about order entry, as we've been discussing, in a much more integrated fashion into this ClearHair system. Now, one way which we currently close these knowledge gaps is through the use of cell phone applications or through reference texts or reading guidelines. But the big problem is that none of this is integrated into the care workflow. It's time-consuming to read these resources. They're not precise enough, and they ultimately don't verify if you made a mistake or not. And what we do today, I guess, as a workaround is that because the order entry tool is disconnected from the knowledge step, we're lucky that we have smart pharmacists. And so a smart, attentive pharmacist might be able to verify if a drug itself is rational, verify if the dose is reasonable, and be this double check that we're trying to build into the clinical system a lot more concretely into the EHR. But the reality is that many hospitals, many clinics don't have full-time pharmacy or any pharmacists at all. And it's unreasonable and quite inefficient to expect a pharmacist to re-verify every physician's order, to re-verify their logic, and then have to contact the physician because they entered the wrong drug and wrong dosing. Now, unfortunately, some pharmacists do this, and they pay special attention when they know that the order came from a physician who's not very good, but it's not a scalable or sustainable model. And so when we look to the future, it's very exciting because we can see right away all the areas of innovation which need to occur in order selection tools. We need tools that help guide clinicians to the right order quickly, tools that help clinicians at whatever step they might be stuck. For instance, they might be stuck trying to convert from oral dosing to an IV dosing for a medication. And then these tools need to be created by third-party vendors, universities, startup, legacy companies, and the development of such tool requires lots of expertise from physicians and pharmacists, and then ultimately that each tool probably needs to have some sort of a certification, either through national or international safety standards. They need to be rated based on their efficacy, and they should be easily able to just plug into the EHR and then exist in a different business models so that those who embed these types of tools and subscribe to them perhaps pay per use or pay per annum back to the person who created these order selection tools. In the next post, what I would like to discuss is moving from order to action and why it's really important that these two are not considered as separate steps, but that the actual placing of an order needs to be integrated into a complete workflow step. And we've done a great disservice to patients and physicians by separating these two steps out, and this is why physicians who use EHR inboxes hate them, and that's why they're exceptionally dangerous. And so that will be the topic for one of the future posts upcoming.